Yeah, hi everyone. So myself is Anand. So I'm an embedded software engineer. So I'm planning to teach you on Linux kernel module. So today what we are going to explore is the basic kernel modules. How to write a basic kernel modules. So most of the folks are interested in learning the kernel modules, how it works, how it interacts with the hardware, and those stuffs. But today what we are going to look is like just the basic kernel modules, how to write. Okay. So I have checked the kernel modules. We have written a simple kernel module, say like hello world kernel module. So how we write when we start a programming language, when we will be writing a hello world.c program, right? So printf of hello world, so similar kind of thing. So how to write a hello world kernel module, so similar kind of thing. So okay, so here you can see, let's you are able to see my screen. So we'll go to the, so I have, okay, one program called simple.c. Okay, so this is the program called simple.c. Let's open that program now. Okay, that's program. So this is the simple kernel module program. If you can see and realize that, okay, just 4 lines or it's just like 25 lines of code, it's sufficient for the simple kernel modules get executed in the Linux machine. So, and one suggestion is important here. So when you are writing a kernel modules, and if you are trying to execute the kernel modules and running the kernel modules of into your system or laptop, so please use the VirtualBox, which installs the kernel modules over there, and then there you can run. So what happens is the kernel module directly interacts with the kernel, so that if anything, if you try to reference a null pointer or something like that, it really crashes the system. So for the safe position, please make sure that you use the VirtualBox, which runs on a kernel, Linux kernel, any OS. It doesn't matter of which Linux Ubuntu version you are using. It doesn't matter that. Okay, so that's how I'm using the Oracle VM VirtualBox, and I'll go over there and writing the kernel module. So let's go over in depth section. So here you can notice these are the header sections. So this is the init section of the kernel module which will be used, and the kernel related APIs which can be used like printk or all those things. Stuffs will comes under this kernel.h files and module. So this module init, module exit, and the macros for module description, license, and author. So all those macros and functions supported in the definition prototypes are available in the Linux module.h file. Okay, so like similar like in application program. So whenever the application program .exe or .ao.out in a Linux, if executes, the main function will get executed. So similar kind of thing, there we have two module entry functions. We call it as two module functions, entry functions. So one is the, whenever the module gets loaded, the simple entry init functions. So init functions will get loaded, which means whenever you're trying to load one new module, it adds additional features to the kernel so that it executes the initialization of the module. So it takes place what are the initializations needed to be handled. And when you are trying to unload the module, so you think that, okay, this module usage is not no more is present because the external device whatever disconnected is moved, or something like if you feel I don't need this module to be used now or consumed, so then you can remove the module. So when you remove the module, if a freeing up the source or resources and the memory constructions can be executed under this exit section. Okay, this comes here. So yeah, so that's the syntax of the module entry function is like we have to provide the return value which is of type int, and the function name, any name you can provide. That's your custom name. So I have given since the application name is simple, so I have given simple underscore init. So it doesn't take any argument. So to confirm that this function is executed when the module is loaded, so I have added a print k saying that simple kernel module entry function, and it returns a 0. So if the value, if the module, if this returns 0, the kernel understands that, okay, the module is loaded successfully. If we return -1 or other value, then it assumes that the kernel module has some issue, and it doesn't during the init section of the module load, and it assumes that it will not allow the OS kernel to load the module. That's the reason we have a return value as 0 for success. For the exit scenario, for whatever may be the scenario, just cleaned up the resources and releases the resource which are already consumed. So it doesn't take any argument, or it doesn't take any argument, or doesn't return any argument. So similar to the init function. So this function name also can be user defined. Okay, So same thing here, I have added a print statement to make sure this exit functions getting invoked, getting invoked when we unload the module. Okay, to register this to those functions, so to register those functions to the kernel, so we have API, I mean macro called the module init, module underscore init, and module underscore exit. So we have to provide the function name of this, which is basically, so we are providing the function name. So what it does is, so the kernel maintains the table, so that tables just we are appending the simple init and simple exit functions. So these are the kernel init functions. So whenever the kernel init happens or the module loads, this function gets triggered as part of the kernel source code. Okay, so and then standard practice of when we write the kernel module, so we have basic informations we have to provide as part of this kernel module. So since it is a kernel module, so we are providing why this module is created. So basically, like we have to give some short description on the module name, and we have to provide the licensing also. So licensing, like this is like a general public license, so that license informations we have to provide. And then module author, so who is developing the author in this module. So basically so currently is my, so I have given my name. Okay, okay, this is the code, yeah, upflow. So this simple code, you see that there's not much complex in this. So now we are going out. So to compile this kernel modules, so we need a make file. So let's say we have a make file, we need to create a make file. So I have created a make file. Let's go to that. Ignore about this line number 2 and 3 currently, so we can focus only on the line 1. So object obj, so obj hyphen is the object file we are going to create. Hyphen m, we have a three options, one is n, one is y, and one is n. So when we mention n, okay, it doesn't mean that this kernel module will not be compiled. So we are not compiling the kernel module, that's the one. And when we mention m, which means that the module is compiling as a kernel module. It's a kernel loadable module. So we call it as a kernel loadable module, which means it will not be compiled as part of a Linux image. That's the main reason. And if we make it y, which means the static image, so when we compile this kernel modules, it will be compiled as part of the kernel image. So when you load the kernel image into the system, then directly this module also will get loaded automatically. Okay, so when you do this load module, list of modules, if you find out, then you can see. But since we are doing this separately, so this will be compiled as part of kernel loadable modules. So that's the reason we have mentioned hyphen m option. This plus equal to, it's appends the module. So already whatever the modules we have, we are just appending to the new module called 0001 simple.o. Okay, so ko files, it will be generated as a part of this. So we are telling what we are expecting from this when we compile. So when we compile, we are expecting 0001.simple.c file. From that c source file, we are expecting object file. Okay, okay, so when we run a make, it execute it search for the target called all, and it under the target we have a recipe, we call it as a recipe. So make hyphen c, so the make is the command, though we use a make build system to compile this our kernel modules. Okay, so we have a make and hyphen c. Okay, hyphen capital C, this hyphen capital C, what it does is it changes the directory, which means wherever you're executing make file, it redirects the directory to the lib module in this in shell hyphen unamr. The shell hyphen unamr is what it means. So what it means, let's show that here. Uname hyphen r gives the current kernel module. This is present here. So 5.4.0 150.generic, it's in my system as of when I'm taking this video today. So this will be filled out here and this build. So this, what why we mentioning here is we are compiling our kernel module with respect to that particular version. So this under the build folder has the header files and the prototypes of these functions, so using which we're compiling. So because we are generating the object file, and this m is nothing but so current directory. So we have a module in the current directory, so that's why we are giving a pwd is part where which the make file is present now. It's where the modules also is present, and this is the target we call it as module. So we have a targets like modules, module all, module install, something like that, and then clean. So we are providing a module here. So it compiled as part of, when you provide this module is the target to the make file for this command. What it does is basically it compiles our code into the kernel modules .ko file. It provides output of .ko files. Okay, so if you want to clean, like after compile the generated ko files, so if you want to clean up, then you can use clean option. Okay, okay, let's go there. So okay, let's list out these files whatever the present. So currently I have 3 files. So currently we are focusing on the first function what we are going to execute. Okay, so we have a one make file. The m should be capital, remaining all are small letters. Please make sure this should be the case. And then what we need to do is we need to run a command make. That's it. Okay, just run a command make. So you can see now, so how this flow executes. So see, make -c, it directs, this is the one, it the expansion of our command. You can see this, and the pwd is currently holding to the current folder where I am executing, right? So home, km, and boot os learning, and then the modules. So what make does, entering a directory, so just jumping from this directory to this path. So that's what here it is. Basically it's jumping to this path. Okay, and home, and then moving out from, it's cross compile the simple IO file. So other files you will leave it about currently because we are not focusing on those. So just compiled that file and creates a .io file and build module stage 2. So what it does is mod post 3 modules. So currently we have compiled 3 modules, but we are focusing for the first module. So this 4 first modules will be executed. It's compiled here. Okay, so linking stage is done, cross compiled, and then linking also is done. So then finally it generates a simple ko file, so kernel object file. So we call it as a kernel object file. Okay, that's how. So next what we do is, just if you do ls and throw the main, if you do ls, what happens, you can see we have a source file .c file for the corresponding mdo.c file and simple ko file. So this is the file which is main information has. This is the module kernel object file which will be loaded in our system. Okay, so what we do is, so to get, okay, to get the information about the file, so which we compile for which architecture, that if you do 001 some file simple ko file, if you see this is compiled for the it's a ko file. It's a 64-bit architecture, LSB relocatable, and x86 64 machine. We compile for this machine. If you try to load this in NOM, it will doesn't work because that's the isn't just for information. And if you need to know about the module, so mod info is the kernel command, I mean user mode command, which gives the information about the kernel module which you are going to load it. So this, we see this one simple simple.ko. See, it gives the information, right? Here this is the file name where we present, and who's the author is myself. License what we have given, that macros, 3 macros whatever we have filled, that those informations are getting processed here, right? You can see, and red point and dependency. So and where magic is version magic. So this is the one, and for which kernel versions we have compiled. So that's the one. Red pole is why something like out of tree, which is compiled for the out of tree. Some that is its mentions about that. Okay, okay, okay. So let's see now the message. So okay, before loading the kernel module, I just want to see this. I want to delete. So if I want to clear out the kernel buffer, kernel buffer. Okay, so okay, vi give it a simple. Okay, so sudo dmessage -c km. So d message, if you see this one. Okay, so now if you see the d message, so I'm clearing out the kernel circular buffer. So I have cleared out this kernel circular buffer so that we can see our logs alone. Okay, so what I'm doing is sudo insmod. So insmod is the user mode command which loads the kernel module into the kernel system. Okay, so 001 simple ko file. So if you do load this, okay, your module is successfully loaded, it doesn't throw any error. So if you see the message, if you see, you can see the message which is printed now, simple kernel module entry function. So our entry function of the simple underscore init function is getting executed. Okay, so if you want to know ls mod gives the list of modules currently present in our system. So I just want to see only list of first 10 modules as enough for me. So pipe symbol gives the output of this ls mod, which throws an input to the head, and it says, and head gives the list of head gives the starting 10 information. So I'm mentioning icon option 10 gives the to print me the log only first 10 lines, so that information is provided here. So that's the command using. So ls mod gives the list of module. from the list of modules, the pipe output, it's thrown to the input head here. Okay, input to the head, and it gives only 10 lines. So let's see this one to make sure how it goes. So you can see now, so it just listed out 10 lines. Okay, from this line. So you see 1 2 3 4 5 6 9 10, right? So you can see our module called 001 simple module is loaded. You can see the size of the module and used by and whatever some other informations. Okay. Okay, so now what I want to do is I just want to remove the module from the kernel. So I can remove the module. Similarly, we have a rm mode is the user mode command which removes the kernel module which is running in the system. Okay, so just type 001. This just gives the tab, it gives the module currently running. If you do enter, okay, current module is removed successfully. If you see this one, so exit function is getting called here. That's it. So that's it about the basic code or basic to create a kernel module, simple kernel module function. So how this d message comes to this file is basically this print k is kind of a simple application similar to our application code only, a printf, right? Similar to that, this buffer outputs will be filled into the kernel circular buffer. So kernel has a circular buffer, so it just throws those informations to that kernel buffer, and if you want to see the kernel buffer information, you can use the dmessage command. Dmessage commands it gives. So basically, if you type a dmessage normally, it has a huge number of messages. So if you want to clear out the kernel buffer, you just type the sudo dmessage -c. So it clears the circular buffer, and it will be a fresh. It doesn't have any message after that. You can see empty. That's how. Okay, so now successfully we have learned how to write a simple kernel modules, and what and the things are involved in the kernel modules and functions. Okay, hope you have learned something from this video, and please put a like and subscribe. Thank you guys.